Hey everyone. So you got this assignment just titled percent increase slash decrease homework. Let's go ahead and go through it. So the first screen asks you to match each situation to a diagram. So we got these diagram A, I didn't mean to do that. Diagram A, B, and C. I will line them up backwards, CBA. And so when I look at the diagrams, I see that in diagram C, the Y quantity, which we always think of as our new quantity that we get after the percent increase or decrease, is much smaller than the original quantity, which is always X. So if something gets decreased by a lot, I'm going to probably match it up with diagram C. When I look at diagram B, I notice that the Y quantity, which is the new quantity after the percent increase or decrease, is also smaller than the original quantity, which is X, but not by nearly as much, right? It's only a little bit smaller. And then when I look at diagram A, I notice that the new quantity is much larger than the original quantity. And so if one of them has a percent increase in it, it's probably going to go with diagram A. And so now that I look at the questions, actually, I see that they're not really in the form of percents, they're in the form of fractions. But this one right here says that Huang runs X miles. I didn't mean to connect that there. And Nikisha runs 3/4 more than that. So we're talking about 3/4 or 75% more. That feels like this increase diagram here to me. And then this one says Huang drinks X. Dang, it keeps connecting to stuff that I do not mean for it to do. Huang buys X pounds of almonds and Nikisha buys 1/4 of that. So 1/4 of something is like kind of a lot less. That looks like this diagram to me. And this one says Huang drinks X ounces of juice and Nikisha drinks 1/4 less than that. So 1/4 less just means you take a fourth off of something and subtract it off. And so that's not quite as big of a reduction as the other one. So I think that's how they should go. Okay, so a pair of sneakers was purchased for $120, but since the purchase, the price of the sneakers has increased by $15. All right, so let's see if we can work this out. I don't have my little pen drawing thing that usually helps me do this, but what we have here is we have an original price of $120. And we want to increase that by 15%. Well, our original quantity is always thought of as 100%. And so when we increase that by 15%, we get 115%. So I'm going to write out 115% here. That's supposed to be a 5, kind of an ugly 5, but this is really hard with a trackpad. I wish I at least had a mouse. Do I have a mouse around here? Oh well, we'll go with this. And so I need to do 120 times 115% to get the new increased price. But I don't multiply by 115%. I multiply by the decimal version of 115%, which would be 1.15. So I wonder if this one gives me a calculator tool here. Do I get a calculator here? Yes, I do. So let's see here. I'm going to do $120 original price. My Zoom bar is like in the way here, times the decimal version of 115%, which is 1.15. And we get $138. And I can actually just submit it just like this. And Desmos will read it as $138, and that's my answer. All right, so here we want to write a situation that matches the diagram. Let me get the work off the screen from the previous. So we look at this diagram. This part right here is our original because it's covered by the X, and X always stands for the original amount. And then this right here is extra. And so what I see in this diagram is some amount that was broken up into 4 pieces, and then one of those 4 pieces was added on. So like maybe each one of these is worth 2. That's supposed to be a 2. It's a terrible 2. There's a 2, 2, and 2. And so maybe the original amount was 8 and it got increased by 25%. So they added another 2 on and then it became 10. And you might be asking, well, wait, Mr. Thomas, how do we know that this is something that was 8 and was increased to 10 and not something that was 10 and decreased to 8? So that's where understanding which one is X and which one is Y comes into play, because I see that X, standing for the original, is covering over 4 boxes, and Y, which means the new, is covering over 5 boxes. So this must be a case where the new quantity is bigger than the original quantity. And so you could write any situation here where something is being increased by 25%. It's being increased by 1/4. So I'm pointing at this box again, because this box is the same size as those 4 red boxes, each of which represents 1/4 of our original number, and a fourth is 25%. So write any situation in the box that describes something being increased by 25%. All right, next we have, at the beginning of the month, there were 80 ounces of peanut butter in the pantry. I feel like that's a lot of peanut butter. 16 ounces is a pound. It's like 5 pounds of peanut butter. Okay. Since then, our family has eaten 30% of the peanut butter. This family eats a decent amount of peanut butter. Which expression represents the ounces of peanut butter left in the pantry? Okay, so the amount of peanut butter that they started with is what we would consider 100% in this case. And then they've eaten 30%. And so we need to take away that 30% from the 100. And we have 70%. So in order to figure out how much is left, we need to calculate 70% of the 80 ounces they started with. And so that would be 80 times 70%, but we don't use 70%, we use the decimal version of 0.70 or 0.7. So any of these answers that say 0.7 or 0.70 times 80 are something that I would choose. And so I would choose this one. I would not choose this one. I would not choose this one. And I would not choose this one. This one would work if they somehow gained 30% of the peanut butter instead of eating it. But nope. So only that top one. Number 5. A dog weighs 20% more than it did 3 months ago. This must be a little dog growing up. Someone's knocking at my door, but I'm not going to answer it because I'm filming. So a dog weighs 20% more than it did 3 months ago. It weighs 36 pounds now. So how much did the dog weigh 3 months ago? Okay, so this is one of the more confusing types of questions, because we're told what the percent change was. It looked 20% more, so something increased by 20%. But instead of being told what it was before the increase, the original amount, we're being told what it was after the increase. And these ones are always a little bit trickier. Let's go through it. Okay, so I'm going to make one of these tables. These tables are good for this sort of stuff because hopefully you see it sort of like proportional relationship stuff. So I don't want to write a whole lot because it's a pain in the butt with this. So I'm just going to put O over here for the original weight of the dog, and new, or N, over here for the new weight of the dog. And then let's put the information we do know. We do know that the original weight was what we consider 100% in this case. We always think of our original as 100%, and then we kind of go from there. Well, the dog now weighs 20% more. And so the new dog's weight, or the dog's new weight, I should say, can be represented as 120% of the dog's original weight, right? 20% more than something that we're considering 100% can be represented as 120 total percent, 100 plus 20. And they told us that the dog weighs 36 pounds now. So that's its like current or new weight. So that goes over here in the new weight category. And our job is to use this 36 to figure out what the original weight was. And so if you think of original as being like X and new as being like Y, thinking back to our proportional relationship days, well, all you would need to do in this case is find your constant of proportionality, and then to go from Y to X, like sort of the backwards way, we divide by our K. And our K is just going to be the percent in this case, because we could do Y divided by X, which would be 120 divided by 100. But when you do that, dividing by 100 just moves the decimal point over 2 spaces. 1, 2, and we get 1.2, AKA the decimal representation of 120% is 1.2. So we're just going to divide by that. We're going to divide by 36 by 1.2 to get our answer here. So see if I can just punch it in here. We go 36 divided by 1.2, and we get 30 pounds. So 3 months ago, the dog weighed 30 pounds, and it's gained 6 pounds since then. Okay, let's get that stuff off the screen, and let's do another one. It says Jessica estimated that her family used 30% more water this month compared to last month. They used 12,000 gallons of water last month. That feels like a lot. 12,000 gallons in a month? Okay. I don't know. How much water did they use this month? Use the sketch tool to complete the double number line diagram if it's useful. I don't think I'll use the double number line diagram. If you want to draw something there, you can. Okay, so this is the easier type of question in my mind, because they've given us the percent change, 30% more. And they've given us the original amount because they told us how many gallons of water were used last month. So let's make a table like we did last time. Those are good. So I'm going to put, how about this? L over here for last month's water, but that's like our original amount in this case. And then I'll put T over here, the weird T, but T over here for this month's water. And so since last month's water will be like our original comparison number in this case, that will be our 100%. And it tells us that they used 30% more this month. So we tack that additional 30% onto what we considered 100% already. And so that would be a total of 130%. And then the only other piece of information we were given is that last month they used 12,000 gallons. Well, to go from X to Y here, or L to T, I should say, we're going from 100% to 120%. And to do that, you would multiply by 1.2. So that's a multiplication dot times 1.2. But that's the same thing. Sorry, I couldn't read my own handwriting. We're going from 100% to 130%. And so that's times 1.3. So I'm going to turn this 2 here into a weird 3. So I meant to say 1.3. But that's the same as the decimal representation of 130%. If you move that decimal point 2 spaces, you get 1.3. So seeing the percent that matches the part as the same thing as the constant of proportionality that you would multiply or divide back and forth across the table is like a really helpful way of thinking of these questions. So we just have to take 12,000 and times by 1.3, and we'll figure out this month's water usage. So I'm going to punch it in here. 12,000 times, I guess I could have done that on the keyboard, but whatever, times 1.3, 15,600. And let's move on to the next one. A bakery used 25% less butter this month than last month. Okay, so we have a percent change here. It's a percent decrease this time, 25% less. The bakery used 240 kilograms of butter this month. Okay, so this is another one of those weird ones where we're given the percent change and the new amount instead of the original. And so this is going to require us to work backwards and divide. So this time I don't think I'm going to take the time to draw the table and all that stuff. I'm just going to hope that you're kind of getting the point because you've seen 3 of these in a row now. So we have our percent change, but it's 25% less. So I think, okay, my original is 100%, and I'm taking away 25% from it. That's going to give me 0.75, 75%. So I am going to write that over here on the side. I'm going to remind myself that the percent I need is 0.75. And now I have to think, okay, well, they gave me the new amount. In order to work backwards to the original, I'm going to do division. I'm going to do new divided by percent equals original, which is literally the exact same thing as part divided by percent equals whole. If you remember that from a couple weeks ago, it's the same thing. We're just using different terminology. So let's take our part or our new number, 240, and divide it by our percent, 0.75. And there we go. It should be 320 kilograms. It's a lot of butter. 320 kilograms. I forget how many kilograms there are to a pound, but it's like 600 pounds, something like that. The butter must be a big bakery. Well, I guess for a whole month, maybe that's not that much. 20 pounds a day. So, geez, yeah, that's kind of a lot of butter. All right, let's do this one. Each week, the price of oranges at the farmer's market increases by 20%. The price of oranges this week is $4.50. What was the price last week? Okay, so this is another one where we're given the percent change. We're told that it's going to be an increase of 20%. And that the price of oranges this week is $4.50. And so we have to find the price last week, which is before the increase. So this is like doubly weird because we're told about an increase, but since we're thinking backwards to last week, no, you know what? I'm gonna not finish that statement because that would have just made things more confusing. So let's just revert back to the table. Let's just go back to there. I didn't make a table on the last one, so I will on this one. I'm just going to use O for original and N for new, but original will be like last week's price and new will be this week's price. And so the original is always 100%. And the new in this case is going to be 120% because it increased from the previous week by 20%. And then the only other piece of information we were given is that the price of oranges this week is $4.50. So that's the new amount. Fives are really hard. And so to work our way backwards to the original, we have to divide by our K. And our K in this case is always the decimal version of the percent that matches the new amount. So in this case, I put a decimal point there. It shouldn't really be there. But it's going to be 1.2, right? 120% as a decimal is 1.2. So let's punch that in here. We're going to do $4.50 divided by 1.2. So the price of the oranges last week was $3.75. All right, and the last one is this explore. So you got to use the digits to try to match something with this double number line. So whatever number you decide to put here in the 100 spot, you got to be able to use 2 digits to create 75% of that number. And you have to be able to use 2 digits to create 30% of this number. I have not actually done this yet. My first instinct would be to try 50 because then no, so I already know that that's not going to work because since 50, well, wait, 75% of 50, each 10% is 5. Nope, I think that's going to come out to a decimal, so I don't think that's going to work. So we need something so that 75% of it is a whole number. About 60. Because 25% of 60 is 15. So if I take 15 away, I'm left with 75%. That's 45. Oh, wait, but I might have made this number too big because now 30% needs to fit here and it has to be a single digit number. Let's see here. And I know that every 10% of 60 is 6. So 30% must be 3 times 6, which is 18. So 60 is too big. So now I learned something about the problem by doing it, that the whatever number you put over here where I put 60, it's got to be considerably smaller. Maybe 20. I put 20 here. Every 25% of 20 is 4. No, 5, I mean. And so take away 5 to get 75%, and we got 15. I think this is going to work. And then 30% of 20, well, every 10% of 20 is just 2. And so 2 times 3 in order to make 30%, we get a 6. I feel like that solution right there works. All right, well, I guess that's it. See ya.